Hello everybody, now we are going to solve a problem from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. This is question number 6.12 and the question is a voltage of 30 into e power minus 2000 t volts appears across a parallel combination of a 100 millifarad capacitor and a 12 ohm resistor. Calculate the power absorbed by the parallel combination. So this is given. For this there is no figure given, so we are drawing the picture, we are drawing the diagram. So this is your voltage source and the parallel combination of this 100 millifarad capacitor and the resistor of 12 ohm is drawn here. So for this we mark the currents like this. The current which is flowing from this voltage source can be taken as I, and it is branching into two currents as IC and IR. So IC is the current which is flowing through the capacitor and IR is the current which is flowing through the resistor. This IR can be written using Ohm's law as V by R, as that voltage by resistance. So what is the voltage which will be appearing across this resistance? That can be taken as VR. That is nothing but this 30 into e power minus 2000 t only, because it is, these components are parallel to this voltage source, so the same voltage will be appearing across these components C and R. Okay, so it is 30 into e power minus 2000 t divided by the resistance value is 12 ohm. So this is equal to 2.5 into e power minus 2000 t. This is the current through the resistor. Now current through the capacitor, that we can calculate, right? So this IC is equal to, formula is C into dV by dt. C value is 100 millifarad. So it is 100 into 10 power minus 3. D by dt of this voltage. Voltage is 30 into e power minus 2000 t. So this is equal to, you can bring this 30 outside since it's a constant. So 30 into 100 into 10 power minus 3, then d by dt of this e power minus 2000 t, isn't it? So d by dt of minus 2000 t, that can be written as minus 2000 into e power minus 2000 t. So if you cancel this, then we get this as minus 6000 into e power minus 2000 t. So this is the capacitor current. Now we want to find out this total current I. So this total current I is the summation of this resistance current as well as this capacitance current. It's the summation of both. So this is equal to 2.5 e power minus 2000 t, then plus this, actually we have this minus sign, so we can take the minus sign, 6000 into e power minus 2000 t. So this is equal to, you take this e power minus 2000 t outside, then we get this as 2.5 minus 6000. So this I is equal to e power minus 2000 t into minus 5997.5, or I can rewrite this as I is equal to minus 5997.5 into e power minus 2000 t. This is I. We are asked to find out the value of the power absorbed. Okay, so the formula is P is equal to V into I. So what is the V value here? It is 30 into e power minus 2000 t multiplied by the psi value, that is minus 5997.5 into e power minus 2000 t. So this is equal to, so minus of 179925 into e power minus 4000 t, this much watts. Or you can write it as minus 179.925 into e power minus 4000 t kilowatts. So this is the absorbed power. Okay, thank you.